Hey everyone. So now this is a program to study autocorrelation. Okay. So you all might be curious, what is this autocorrelation? So if at all you really want to do it, let us understand this particular term called as cross correlation. So let me use this command prompt here just to convince you what is this cross correlation. So the command is XCOR, COR. Okay, okay. So X stands for cross. Okay. So let me take a numbers here. Two sequences I will take. So first number is say 1, 2, 3, 4. That's my first sequence. The second sequence is 1, 1, 2, 1. Okay. So I have an answer here 1, 4, 8, 13, 13, 7, 4. Now what I will do is I will just convolve. I will convolve the first sequence as it is 1, 2, 3, 4. Whereas the second sequence, what I will do is I will just flip it from left to right. Okay, so that would be uh, 1, 2, 1, 1. Did you get this thing? What did I do? So instead of writing it from left to right, I wrote it from right to left, 1 to 1, 1. And you can see both my convolution and correlation gave me same answers. So that means that convolution and correlation are so much related. You remember the expression y of n equal to x of k h of n minus k. If that is convolution, y of n equal to x of n h of n minus k. That is correlation, right? X of k h of n minus k here, x of n h of n minus k. Or equivalently, you can see first sequence and convolved with second sequence flipped. It gives you same as that of correlation. Okay. So in communication, basically for synchronization, all those things in radars, we usually use correlation, whereas the whole hardware, whatever that is used for the convolution, which is filtering, and for correlation, both hardware is same. Okay, only thing is while giving the inputs for the same hardware that you use for convolution, if you flip the second sequence, it the same hardware will get you correlation also, but the application cases are completely different. Okay, so what is an autocorrelation, by the way? Autocorrelation is a special case where both the operands, okay, so in this particular cross core, if at all I give only one operand, that means it will convolute the thing with itself or correlate the thing with itself. So it is same as that of, say, let me CORR. Now what I will do is I will do the same sequence. What 1, 2, 3, 4. Along with the second sequence, I will give as 1, 2, 3, 4. Okay, so there I get an answer. So what's my answer? You can see 4, 11, 20. So this is 1, 2, 3, 4 convert with 1, 2, 3, 4. What if I give only one operand here? I give a cross core. I simply give 1, 2, 3, 4. I did not give the second operand. What happens? You can see the computer automatically took the second sequence as the same sequence, and it simply calculated the correlation, the cross correlation of the signal with itself. So that's called as autocorrelation. Okay, so let us see. Very strange, right? Why would somebody correlate a thing with itself, right? Okay. So let us see it with an example once again. Let me run the program. And what is the thing, by the way? We want to, understand some properties of autocorrelation. What are the properties of autocorrelation? So first property of autocorrelation is the midpoint of the autocorrelation usually gives the energy. What is energy? Sum of squares of all the values. That is energy. And in autocorrelation, the midpoint usually is the energy. That's the first thing. Second property that we want to know is autocorrelation function is usually symmetric. The values on the left half and the values on the right half are going to be symmetric. Okay. So this one thing we want to observe. And then periodicity. There is this thing with periodicity. That means if at all you have some pattern in a sequence using autocorrelation, you end up getting some peaks at the at certain periods, and the difference should usually give you the any pattern, hidden pattern in the signal. Let us see them one by one. Okay, so let me run the thing, run the code. Okay, so did you see the code here? So you can see there is nothing much here. Okay, so cross core is the code. Usually, as I told you, MATLAB starts from 0, sorry, 1 onwards. Actually, correlation is a symmetric thing, minus n to plus n thing. That is why the small adjustments we are making here. Okay, L is the length, by the way. So do not get confused between 1 and an L. Okay, so this is a 1, this an L, and let us see. And here I just want to check whether the midpoint is actually the energy. That is why you know this term here, energy, sum of squares. Okay, it's dot power. Okay, that is a scalar, sum of squares individual. Okay, it's not a vector operation, a scalar operation. Okay, and the center value is what's being checked. Okay, so let us give this a try, and let me run the code here. Okay, so here you can see in the command prompt I'm being asked to enter the sequence. Let me give some. I'll give a simple sequence. So 1, 2, 3, 4. Okay. So now let us see. Is there any pattern in the sequence? Nothing, right? It's just increasing thing, right? That's some nonsense. 1, 2, 3, 4. And what are you expecting by the? What is the energy of the sequence? Energy of the sequence is 4 square plus 3 square plus 2 square plus 1 square. That is 16 plus 9 plus 4 plus 1. How much is that? 16 plus 9 plus 110. That is 16, 24, and 4. Is it so? Is it so? That's so difficult, right? 16 plus 10, 26. Okay, let us see. Let us see this thing. Okay. So sum of squares is your energy. Now let me press an enter here. What just happened? Okay. Yeah, not that bad after all, right? So it was what you can see the energy is 16 plus 9 plus 4 plus 1, that is 30, and as expected the midpoint is energy. Is it so? Let me show you the graph. Let me show you the graph. Then here you can see we checked for the symmetry, and the one command which you have used here is a new command, that is flip left to right. Okay, flip LR. So what this command does, it takes the sequence 1, 2, 3, 4 and it compares it with 4, 3, 2, 1. Okay, so what does that mean? By the way, you can see here actual command answer is this 4, 11, 4, 11, 20, 30. You can see here 20 and 20, 11 and 11, 4 and 4. The values on left and values on the right are symmetric. How do you check this thing on a computer? So what we'll do, we'll take this particular sequence, and if at all I do flip left to right, the entire sequence will be made ulta, right? So this last value is going to come first, right? Should I show you one? Okay, wait a second. Flip left right of say I have a sequence something like say 1, 2, 3, 6, 7. Okay, so this is what's going to happen. Okay, so if at all the answer what we got here was this was the answer, right? If at all I flip it from left to right, and if at all I compare, if the answer is symmetric, I should get a 0, right? And if condition should be satisfied. So that is where I had decided to display this autocorrelation function is symmetric or not. Okay, so let me go to the graph now. I will show you the figure. Okay. So here you can see this is the figure. So what do you think? Is it symmetric? Yes, it is symmetric, right? Values on the left and values on the right are same. Okay, and you can see value in the center. That's my 30. And periodicity, there was nothing much in the, there was no pattern here, right? So now, so every program you have to use some sensible inputs to get some sensible outputs. Let us do that exercise now. Let me run the program once again. Okay, so I will run the program once again. So I will enter some spooky sequence, and you'll see if there is any pattern in it. Okay, so pattern in this. Do you see any pattern in this sequence? You see any pattern in this particular sequence? Very random. 8 0 5 0 5 6 8. Right. Do you see any pattern in this? Now we'll press an enter now. We'll press an enter now. Okay, autocorrelation function is symmetric. The midpoint give you the energy. Fine. Now let us go to the figure. Now let us go to this figure and let us see what happened. Okay, so there we have the figure. Let me make it a little bigger. What do you see, by the way? Anything peculiar? The symmetry is there. Other than that, the thing that I want you to observe here is, wait a second. Okay, yeah, this particular thing. You can see here is a point, and then here there are some prominent peaks that are repeating. There's a peak here, there's a peak here, there's a peak here, there's a peak here, right? You see these peaks, very prominent peaks compared to all the remaining ones. These are very dominant here. And interestingly, if at all I take my cursor, this one here, let me wait a second, including this spotlight. I don't want it anymore. Okay, let me take this spotlight from MATLAB. Okay, this thing from MATLAB. Okay, you can see this is at a point 0, and then here. Okay, so this is at 0. Okay, and this point here, let me take the second point. This is at 10, and this third point is at a distance of 20, and the fourth one is at a distance of 30. Do you see all these points? The first point, second, third, and fourth, and even on the left side they are symmetric, right? Minus 10, minus 20, minus 30. That means there are some periodic peaks occurring at a distance of 10. Now let me take you back to that signal and let us see if there is anything peculiar in this. Okay. Now the sequence I gave is, can we, okay. Here is the sequence. You see here, this is nothing but 5 6 7 6 3 4. Right. It's the same thing. 8050567634 that is being repeated. It's being repeated, right? So you can see, and we could clearly find out that this is the pattern that is actually repeating. This is what the autocorrelation is all about. It helps you recognize some hidden patterns in any given signals. Of course, even in the presence of noise. Okay, even in the presence of noise. If it all add some noise to this, even in the presence of noise, you will see some prominent peaks. Okay, so that was autocorrelation for us. The properties, the energy property, the symmetry property, and it reveals if at all there is any periodic patterns in the sequence. Okay, these three properties. Other than that, what did you learn? The next thing that we came to know is autocorrelation is very similar to a convolution, where you take the first sequence, flip the second sequence, and simply convolve. Okay, so that was autocorrelation. In the next video, we'll see cross correlation also.